Good morning. In last lecture we have seen about common mode rejection ratios. Common mode rejection ratio is nothing but the ratio of desired output to the undesired output. Whenever CMRR is large, we say op-amp is nice. Operational amplifier is fine if the CMRR is what? More. It is defined as the ratio of desired signal to the undesired signal. If CMRR is large, larger the CMRR, the better is the amplifier. Output of amplifier is very nice. Differential amplifier provides excellent bias stability because of use of emitter bias current. Up to this we have arrived in last lecture. Again you are welcome back in Sanjeevanee Mahavidyalaya Chapoli. This lecture is again for B.Sc Physics second year students. Unit number 3, Operational Amplifier. Paper number 9. What are the advantages of differential amplifier? Whenever we study of differential amplifier, we should know the advantages of such an operational amplifier. Number 1, noise immunity. See, very important it is. When we use a differential amplifier, it responds to the only different signal between input terminals and ignores all common mode signals such as noise pickup and ground voltages. So noise immunity is one of the most important factor in case of any electronic devices. So noise operational amplifier must be what? Noise free. It means it has to pick up only the input and it has to ignore all the signals noise which are noise pickup and ground voltages. So this is one of the advantages of differential amplifier, that is noise immunity. Second one is very important, drift immunity. Then you may ask, what is meant by drift? See, one major problem that arises in amplifiers is that the change in voltage level or value of by the effect of temperature. These changes occur slowly and are known as drift. Differential amplifiers exhibit tremendous ability to eliminate the problem of drift. Yes, you know, in our day-to-day life also, if suppose a conductor you have, any conductor you take, and if we apply potential difference across it, then surely current flows through it. But after a certain period of time, its temperature level increases. As a result, what happens? Its resistance increases. There is change in resistance of a conductor because of the what? Heat or because of the temperature. Because of rise in temperature, there is a rise in resistance, increase in resistance. So in the same way, one of the major problems that in case of operational amplifier, differential amplifier arises that the change in voltage levels or value by effect temperature. These changes occur slowly and are known as drift. What is drift? The changes in amplification voltage takes place slowly because of the effect of temperature, and such changes which occurs slowly, known as drift. But the differential amplifier has a tremendous ability to eliminate such a problem of drift. And this is again the advantage of operational amplifier, that is differential amplifier. The construction of differential amplifier is used in all those circuits where low drift is very important, such as stages of oscilloscope and electronics voltmeter. What are these? The construction of differential amplifier is used on the circuits where the low drift is very important, such as stages of oscilloscope and electronics voltmeter. Now, one more concept is there in operational amplifier, that is input offset voltage. What is input offset voltage? We have seen that there are two inputs, V1 and V2. One is inverting and the other one is non-inverting. Then what is input offset voltage? This concept is very important. It is defined as the voltage that must be applied between the two input terminals of the op-amp to obtain 0 volts at the output. See, ideally the output of op-amp should be 0 at 0 volts when the inputs are grounded. Here I want to clear one point, that in case of the ideal amplifier, one of the characteristics of ideal operational amplifier is that there should be 0 output whenever there is no input. I mean, whenever inputs are grounded, output should not be 0. Output should not be there. It must be 0. But in ideal cases, it is possible. But practically, it's not possible. So, practically, as it is not possible, that's why we have to provide such an input to the operational amplifier. Because of that input, output level must be 0. So it is defined as the voltage that must be applied between the two input terminals in order to obtain 0 volts as the output. So this is offset voltage, input offset voltage. Now input offset current. One more concept is that input offset current. We have seen input offset voltage. Now we see input offset current. Here you see, this is again the op-amp shown here. Input is grounded here. Here also input is grounded with some here variable power supply is shown here. Input voltage is shown here, and output is expected how much? 0 volt. Now there is a difference in the input current that flows in or out of each of the input pins. Even if the output voltage of the operational amplifier is 0 volt, due to the fact the pair characteristics HFE and VBE of the differential transistor do not match, then this difference is known as the input offset current, denoted by IO. So input offset current. Now input bias current. Input bias current is a problem to the op-amp user because it flows in external impedance and produces voltages, which add to system errors. Consider a non-inverting unity gain buffer driven from a source impedance of 1 mega ohm. If 1B is 10 Na, it will introduce an additional 10 MV of error. Input impedance. It is found that the input impedance for an op-amp circuit is at least that between non-inverting and inverting inputs, which is typically 1 N ohm to 10 T ohm, plus the impedance of path from the inverting input to ground, that is R1 in parallel with R2, R1 in parallel with R2. So this is input impedance. Now output impedance. The output impedance of an ideal op-amp is 0. This means that regardless of the amount of current drawn by an external load, the output voltage of the op-amp remains unaffected. Whenever there is no load, the output impedance of an operational amplifier is what? 0. Here you see these two figures. Here output is what? 0. Here output is what? 0. Like. So output impedance of an output impedance of an ideal operational amplifier is what? 0. But input impedance is what? High. This means that regardless of the amount of current drawn by an external load, the output voltage of the op-amp remains unaffected. There is here one point is important, that regardless of the amount of current drawn by an external load, the output voltage of the op-amp remains unchanged. There is no remains unchanged. It remains constant. It will not affect. So in this way, the output impedance of the operational amplifier is what? 0, or we say very, very less, minimum. High input impedance, low output impedance. It is expected for the better operational amplifier purposes. So in this way, operational amplifier has two advantages, that is noise immunity. Second one is very important, that is what? Drift immunity. And the various concepts about operational amplifier: input offset voltage, input offset current, input impedance, input offset voltage, input impedance, the output impedance, etc. Remaining matter we shall see in next lecture. Thank you.